Welcome to the TOEFL listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor, or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Daniel. You said you wanted to discuss your thesis idea on smart city technologies during office hours.
Yes, Professor Morris. I want to focus on IoT integration in municipal infrastructure and explore practical deployments and the planning challenges.
That is a solid topic. Do you have a specific municipal system in mind, like traffic management, waste collection, or street lighting?
I am considering traffic signal optimization and adaptive street lighting together. I think their sensor networks overlap and the data streams can be combined for efficiency.
Combining telemetry from traffic loops, camera analytics, and ambient light sensors can yield richer insights. For example, Barcelona integrated parking sensors and smart lighting into a city platform to reduce energy use and improve circulation.
I read about Barcelona. They used low-power networks for sensors and a municipal middleware to aggregate data. Could you explain the middleware role again in plain terms?
Middleware is the software layer that sits between hardware sensors and higher-level applications. It handles device authentication, data normalization, and exposes APIs for visualization and control. Without it, you get data silos and incompatible formats.
So middleware helps interoperability. Does that mean the city does not have to replace existing sensors when a new vendor comes in?
Exactly. Good platforms support standard protocols like MQTT for telemetry and REST APIs for control. They also map sensor IDs to GIS layers, so planners can visualize which junctions or lampposts are affected.
You mentioned MQTT. I know it is a lightweight publish-subscribe protocol. Why choose that over HTTP for sensor telemetry?
MQTT is optimized for low-power devices and unstable networks. It supports persistent sessions, small packet overhead, and efficient multicast. For battery-powered sensors deployed on street furniture, that is critical.
That makes sense. For wide area coverage, which network technologies are realistic for municipal IoT?
Low-power wide-area networks like LoRaWAN and NB-IoT are commonly used. LoRaWAN is attractive for community-scale deployments because municipalities can operate private gateways. NB-IoT uses existing cellular infrastructure, which can simplify maintenance, but may involve recurring fees.
When sensors transmit data to the cloud, is latency ever an issue for things like adaptive traffic signals?
Latency is a critical design constraint. For adaptive signal control, you need near real-time decisions. That is why many implementations push analytics to the edge using microcontrollers and edge gateways.
So edge computing processes data locally and only sends summaries to the cloud.
Yes, we use edge computing to reduce latency for traffic signal adjustments because sending everything to the cloud would be too slow. Edge nodes can run models that estimate queue lengths and trigger phase changes within seconds.
I see. That also reduces bandwidth and costs. But what about data governance and privacy when cameras and sensors collect so much information?
Data governance is a major planning challenge. Cities must define who owns the data, how long it is stored, and what anonymization measures are applied. For camera analytics, many projects extract metadata, like vehicle counts, instead of storing raw video to protect privacy.
Are there standards or best practices for anonymization in municipal IoT?
There are emerging standards and toolkits. Planners often adopt differential privacy techniques for aggregated analytics and apply role-based access control in middleware, so only authorized applications can query sensitive fields.
How do planners handle cybersecurity for these distributed networks?
Security must be baked into device provisioning, firmware updates, and network segmentation. Municipal deployments use mutual authentication, over-the-air secure updates, and encrypt telemetry at rest and in transit. Neglecting any of these can turn infrastructure into an attack vector.
You mentioned maintenance earlier. How do cities manage battery-operated sensors and actuators at scale?
Predictive maintenance is where IoT really helps. Telemetry on battery voltage, link quality, and sensor health allows operations teams to plan service routes. Amsterdam and some Scandinavian cities use predictive dispatching to reduce field visits.
Can smart city platforms integrate legacy infrastructure, like existing traffic controllers and the electrical grid?
Integration is possible with protocol adapters and hardware interfaces. Many modern controllers expose APIs or serial interfaces. The more challenging part is governance and procurement, getting utility departments and transportation agencies to collaborate.
What about equity issues? Could smart city investments worsen inequality?
They could if deployments only occur in affluent areas. Planners need inclusive policies. Prioritizing zones with poor service or high pollution exposure can use IoT to address inequities, for example by deploying air quality sensors in underserved neighborhoods.
This is a lot to cover in a thesis. Would it be reasonable to do a comparative case study of 3 cities and include a small simulation of edge-based traffic control?
Yes, a mixed methods approach is appropriate. Compare implementations in Barcelona, Singapore, and Songdo to highlight different governance models, and include a simulation that demonstrates how an edge analytics module can reduce delay at an intersection.
Great. For the simulation, should I implement MQTT for telemetry and an edge node running a lightweight queuing algorithm?
That would be both practical and pedagogically useful. Document assumptions about sensor accuracy, transmission intervals, and failure modes. Also discuss scalability and the trade-offs between cloud and edge processing in your conclusion.
Thank you. I will draft a research plan and include literature on middleware, LPWAN, edge analytics, privacy, and case studies. Can we meet next week to review the plan?
Yes. Bring a one-page proposal with your research questions and proposed methods. We will refine the scope and identify data sets or municipal partners.
I will do that. Thanks for the feedback.
You are welcome. I look forward to your proposal.
Listen again to part of the conversation, then answer the question.
We used edge computing to reduce latency for traffic signal adjustments because sending everything to the cloud would be too slow.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit spinta.org.